Hello, my name's Tony J from Eiger Design. In this short video we will show the new features available in the J-Debugr version 1.1.0. So to start we will connect to the J-Testr by pressing connect, scan the slots in the normal fashion as per previous versions. As we can see, we have an LV supply card, a timer card, an LV I/O card, an ADC DAC card, a load card and a motherboard fitted to this system. If we head off to the motherboard tab and go down to a register, we pick in this case the peripheral I/O enable register. If we right click anywhere along this register, you'll see a new pop-up occurs. At the top it describes what register we're dealing with. We are able to do a write on this register, a read from this register, an NSE read. This allows the user to read a register without any side effects. For example, reading a UART buffer register auto increments the internal buffer as a side effect of the read. Reading the same register with NSE read means this buffer would not be auto incremented. This is very useful when you want to have a look at the buffer, the current buffer result, but without moving it to the next pointer. We also have write on change. If we click on this, means that when we write or change the value of a register, for example I just changed the value here to 10, you'll notice that the register has grayed out. It has not been written. It is currently in an unknown state. If I now go to this register, right click and write that value, we see it's gone to blue. That indicates that we have done a write. If we go back and enable write on change, you'll notice if I change this value, for example to 20, we automatically write that value once it has changed. Okay, the last function available on this drop down menu is disable the register. When the register is disabled, it is completely grayed out. We can do nothing with this register. And this is useful when there is a register that you really don't want anyone to mess with or anyone to adjust while you're debugging a program. So to avoid an accidental read or an accidental write, you can disable the register. So if we click back on, we re-enable that register. You see now we can make changes to that register as we see fit. Just a useful point here, if I go to write on change and disable that and mess around with these bits, you'll notice that no write is occurring. It's gone grey to indicate that we're in an unknown state, i.e. the result we're seeing here is undetermined, whether it is in the register or not. If we simply now go to a read, it reads back the value that's actually in the unit, or we can make it say 10 again, and we can do a write and it goes blue indicating that it's done a write. Okay, let's put write on change back. Another big feature that's been added to this version of the J-Debugr is a more reliable highlighting of the value to be changed. In previous versions it was possible to highlight the value and also include the OX, or just include one single part of the number that was displayed. In this version now it is impossible to highlight the OX. It will just go back and highlight the main number, and it is also impossible just to highlight part of this number. So when you change this number, for example if I now write this to 100, which is not possible in this register because it's 8-bit register. Let's write another value. Let's write AA. It's only AA that is highlighted after it's been written, allowing you to change the value. This improves the behavior of dealing with values. Okay, Next we will go to the log. So in the log, everything's much the same. You can see here we've got the dark blue debug TX. That means that it's a transmit from the debugger. And what's new is we've now got a relative timer. So this is when the event actually occurred relative to when the program was started or when the timer was reset with this reset button here. Okay, we'll do an example. I'll set a program running in another window. Okay, so here a program is running, a test program is running in another screen, and you can see here all of the relative measurements right down to the millisecond detail. So we know from one event to another event when that occurred. On to the next feature that's been improved. We had a lot of comments about the default colors, the colors from the previous versions for incoming transmits and receives were not very readable because of the contrast was not very clear. So on this version we've given the ability via the option menu for the user to select the colors. So here we see serial RX and serial TX. That is what we're seeing here. That's from the transmit and receive communications from the UART. We can see them clearly here are the light green and the light blue. Then, as always in previous versions, the JTAG RX and the JTAG TX were also that same color. However, now we've got the choice to go in and change color. So I'm going to change this light green to this sort of orange color, make it a little bit darker, more brown. Click OK. You can see the contrast is much better with this new selected color. We'll select a new one for the serial TX. Let's go purple. We'll make that a little bit darker again, and you can see the contrast compared to the old light green and light blue is significantly improved. We can make different colors for the JTAG RX and the JTAG TX, but we'll leave these for now as an example of how the colors were previous. And also on this demonstration we have no JTAG receives and transmits coming in. So we close that down. We will now run that same program again and have a look at what the difference is. Okay, so now it can be seen to be much clearer. I'll just pause that program in the background so we can actually see. So here, much better color contrast in the log. Okay, let's see how the new color scheme affects the peripheral card tabs. So here we can see that the contrast is very good against the grey background provided by the peripheral card tabs. Here we see the brown color that we selected for external serial write, and here the purple color for serial read, and here is the existing dark green or green color from the J-Debugr read. I'll just do a J-Debugr read here. You'll see that goes to the green color, and that provides great contrast to the read from the serial. That's the Ethernet serial read. Okay, the last feature I would like to show you is the ability to select an alternative configuration folder. So in C drive I've got my config folder, so I select that folder. I just go to comms, slot 0 is type 104, major version 2, minor version 0, variant 0. That will be required to find the correct configuration file. So let's just get that folder up. Here is that file, 104.2.0.0. If we edit this file, edit in Notepad++, you can see here LV supply card. This is actually the text that it shows at the top of the tab. The type is 104.2.0.0. So this is what we're looking for. So we will change the name to Hello register, and a bit name here. You can see bit 0 to bit 15 to hello bit. I won't go into any more detail. I'll let you explore these XML files yourself. They're fairly self-explanatory. If all goes wrong, you can delete that directory and it will revert to the existing configuration files with the install. So we just close that down and save it. Shut down that or hide that. Okay, if we go to comms again, we disable the slots and rescan the slots so it loads in the new configuration files. Yes, we would like to remove the unused slots. If we now go to the LV supply card, you can see we have hello register here, and if we look here, hello bit. Okay, and the rest are bit 1, bit 2 as they were in the configuration file. If we change that alternative configuration back to somewhere which doesn't have the configuration file, so in this case just straight C drive, and go to the comms, disable and scan slots, it still finds the LV supply card, but it gets it from the original location and everything is back to normal. This feature is very useful for projects. If you have a project, for example, that is using the user IOs and you want to identify specific user IOs as, for example, relay or turn on, you can actually rename the bits so that when you're in the debug environment, it's very easy to identify which bit is controlling what function in your tester. That concludes this video. I hope it's been helpful. Bye bye.